Hello my friends, today we will talk about the IP smurfing attack. So what is the IP smurfing attack? It's the attack that takes benefit of the IP directed broadcast feature and uses IP spoofing to flood a host with thousands of ICMP reply packets. So here in this topology, we will attack the device R5 by spoofing its address, the 2.252 on our device R9. Then we will send an IP directed broadcast packet to the network 3.0. Then all hosts in this network will respond to the broadcast, but the replies will come back to the attacked host R5. This means that for each packet we send, we will have replies multiplied by the number of hosts in the network 3.0. Imagine what will happen if we send thousands of echo requests from multiple devices to multiple networks just to attack this single host. The result will be a DOS attack. So let's begin. We have enabled the debug IP packet detail on all routers, and we have spoofed the IP address of R5 on R9. Let us check of that. If we go to the device R5 and check the IP address by using the command show IP interfaces brief, we see that it has the IP address 2.252. If we go now to the device R9 and use the same command, we see that it has the same IP address 2.252. So R9 just spoofed the IP address of R5. Now if we just start the attack by using ping to the IP directed broadcast address of the network 3.0, we see now that R9 is sending the packets and it is received by R1, R2 and also R3, which are the hosts in the network 3.0. And we also saw that the replies just come back to the device R5. So the replies just flooded the device R5. So the attack is successful now. Now, how can we stop that attack? We can stop that attack by using one of two ways. We have two ways to stop that attack. The first one, or the first way, is to just disable the feature, the IP directed broadcast feature on the interface fast Ethernet 0/0 on R4, on the last router, R4. So if we go now to R4 and go to the interface fast Ethernet 0/0, now if we just disable the IP directed broadcast feature and check for that, and this feature is, by the way, disabled by default. It's disabled by default, but now we just disabled it because it was enabled before. So now if we check if it's disabled or not, do show IP interface F0/0, we see that the feature is disabled. Now if we repeat the attack from R9, by repeating the ping, we see that no packets are received by R1 or R2 or R3. And if we go to R5 and check an access list that we have put before, we see that there are about 25 packets received by it from the previous attack, the successful attack. Now if we repeat the ping again to check that, to be sure, if we check the access list, we see that it received about 30 packets. And if we repeat that on R9, we see that the number of packets is now on R5 are now 35 packets. That's because there are replies just come back from R4, this interface. So we prevent the packets from coming to these hosts, but there are still packets come to fast Ethernet 0/0, so the replies just come back from fast Ethernet 0/0 to R5. So the attack is just partially successful, not fully successful. So now if we just enable the feature back on R4, and check for that, we see that the feature is now enabled. If we repeat the attack again from R9, we see that the number of packets on R5 will be increased not just by 5 packets but by 25 packets. So we see now that there are about 55 packets on R5. Now let us use the other way of stopping this attack, which is better than this way. This other way to stop the attack is by using the unicast reverse back forwarding on interface fast Ethernet 0/1 on R6. So what's the unicast reverse path forwarding feature or mechanism? If we go to R6 now, if we use the show IP route command, we see that R6 see that the network 2.0 is directly connected from the interface fast Ethernet 0/0 from here. So it is not logical to receive a packets with a source IP address from or of this network from this interface, because this network is located just from this interface, from the interface fast Ethernet 0/0. So it's not logical to receive packets with the source IP address of this network from that interface. But the routers by default just do not check for the source IP address. Routers usually check or work by checking the destination IP address, not source IP addresses. So how to just make the routers check for source IP address and check if the correct source IP address is coming from the correct interface? We have to use the feature called unicast reverse path forwarding, which will check for the source IP address and therefore prevent R9 from spoofing the IP address of R5. So on interface fast Ethernet 0/1, we just will enable these feature IP verify unicast source reachable via, and here we have two options, any or RX. The any option is check if that source IP address is available or located on any interface, not just the interface that the packet should come from. So if there is a route for this network from any interface, then the packet will just come through, will be forwarded. But the RX option is the strict option, which will check if the packet is coming from the correct interface, the interface which is in the routing table, which is here, the interface fast Ethernet 0/0. So we will use the RX option, which is the more strict option. Now if we just repeat the attack, here we see that R5 just received 55 packet. So we will repeat the attack and see if the number of packets will increase. The R being sending now. If we go to R1, we see that even R1 and R2 and R3 do not receive any packets. Why? Because R6 just dropped the packets that it received from R9, because they are not supposed to come from this interface. And also if we check on R5 and check the ACK list again, we see that the packets are still 55 packet. So by using this feature or mechanism called unicast reverse path forwarding, we have prevent IP spoofing and therefore prevent the IP smurfing attack.